Assalamualaikum warahmatullahi wabarakatuh. My name is Linggar Kahpy. I'm from 3H Manufacturer MSU and my NIM 190241200I. I, I want to explain about concept and definition of thermodynamics. Course Thermodynamics. And the lecturer is Dr. Deanta Mustafa K. Definition of thermodynamics. Thermodynamics, Greek thermos, heat and dynamic change, is the physics of energy, heat, work, entropy, and process spontaneity. Thermodynamics is closely related to statistical mechanics in which thermodynamic relationship originate. This then describes the attempt to convert heat, energy transfer due to temperature difference, into energy and its supporting properties. Thermodynamics is closely related to the physics of energy, heat, work, entropy, and process spontaneity. In addition, thermodynamics also deals with static mechanics. This branch of physical studies and exchange of energy in the form of heat and work, limiting system and the environment. Application of thermodynamics can occur in the human body, the event of blowing hot coffee, electronical, refrigerator, cars, power plants, and industry. Is the thermodynamic event that is close to everyday life. In a system where the process of state change of or energy exchange occurs, classical thermodynamics is not related to the reaction kinetics, the speed at which a reaction takes place. Therefore, the use of the term thermodynamics usually refers to equilibrium thermodynamics, in which the main concept is the quasi-static process, which is idealized. Meanwhile, time-dependent thermodynamics is unbalanced thermodynamics. Since thermodynamics is not related to the concept of time, it has been suggested that equilibrium thermodynamics should be called thermostatic. And basic concept in thermodynamics. The basic abstraction of thermodynamics is the division of the world into a system limit by the reality or ideal of the limit. Systems that are not included in the consideration are classified as environmental, and the division of the system into subsystems is still possible. Or forming several systems into a system. Usually, the system can be given clearly detailed circumstances which can be broken down into several parameters. From the basic principle of thermodynamics in general can be derived the relation between quantity. For example, the expansion coefficient, compressibility, specific heat transformation, and electrical coefficient, especially the properties that are influenced by temperature. The next, the thermodynamic system. The thermodynamic system is part of the universe that is considered. A real or imagined boundary separates the system from the universe, which is called the environment. The classification of thermodynamic system is based on the nature of system environment boundary and the transfer of matter, heat and entropy between the system and the environment. There are three types of system based on the types of exchange that occur between the system and the environment. Number one, closed system. There is an exchange of energy, heat, and work, but there is no exchange of object with the environment. Greenhouse is an example of a closed system where the heat exchange but no work exchange with the environment. Whether a system exchange heat, work, or both is usually considered a limiting property. Adiabatic barrier does not allow heat exchange, and rigid barriers do not allow work exchange. And number two is solid system. There is no action of heat, object, of work with the environment. An example of a solid system is an isolated container, such as an insulated gas cylinder. Number three, open system. There is an exchange of energy, heat, or work, and object with the environment. A concept that allows Jake is called permanent. The ocean is an example of an open system. In effect, a system cannot be completely isolated from the environment, because there is bound to be little mixing even if only slight a surf of gravitation drawn down. In unisolated system analysis, the energy entering the system equal the energy leaving the system. And the state thermodinamika atau keadaan termodinamika. When the system is in a state of equilibrium under definite condition, this is called the fixed state or system state for certain thermodynamic circumstance. Many properties of the system are specified, properties that are independent of the path by which the system from the state are called the state function of the system. The rest of this section consider only properties, which are state function. The minimum number of properties that must be specified to describe the state of a particular system is determined by Gibbs law. Usually, one is dealing with a system property of greater than minimal amount. The development of relationship between properties of different circumstances is possible. The equation of state is an example of such a relationship. Basic law of thermodynamics. There are four basics they apply in thermodynamic system. One, number one, zeroth law of thermodynamics. The initial law states that two systems are in equilibrium with the third system, so that they are in balance with each other. This law was entered after the first law. Number two, first law of thermodynamics. The same law is also related to the case of segregation of energy. This law states the change in the internal energy of a closed thermodynamic system, which is equal to the total amount of heat energy supplied to the system and the work done on the system. This law can be broken down to several processes, namely the process with isochronic, isothermic, isobaric, and also adiabatic. And number three, second law of thermodynamics. The second law of thermodynamics is related with entropy. There is no sound for the second law of thermodynamics. That is only a statement of experiment reality issued by Kelvin, Planck, and Clausius. Clausius' statement, it is impossible for any system to work in such a way that the only result is the transfer of energy as heat from a system with a certain temperature to a system with high temperature. Kelvin Planck's statement, it is possible for system to operate a thermodynamic cycle and deliver a net amount of work around while receiving thermal energy from a single thermal reservoir. Solve fundamental of engineering thermodynamics. Moran Jasapir MM 6 2007 Willis, Chapter 5. Total entropy of an isolated thermodynamic system tends to increase with time approaching its maximum value. This is called the entropy increase principle. This is a corollary of the statement above analysis of the second of law thermodynamics for process using entropy properties, source fundamental of engineering thermodynamics. And the fourth is third law of thermodynamics. The third of law of thermodynamics deal with absolute zero temperature. This law states that when a system reaches absolute zero temperature, all process will stop and the system entropy will approach its minimum value. This law also states that the entropy of a body with a perfect crystal structure at absolute zero temperature is known. Thank you for attention. My name is Linggar Kahpy. See you. Bye bye. Wassalamualaikum warahmatullahi wabarakatuh.